In this video, we present an implementation of a simple IP-based service in both Python and MicroPython for Raspberry Pi and RP2040 Pico-W system-on-chip, respectively. IP and, in particular, Wi-Fi connection were selected because of other protocols require complex implementation specific to the hardware, and regarding Raspberry, they require external modules. Their programming is vendor-specific. The Raspberry Pi's operating system is usually responsible for the network connectivity, so a Python developer can expect a ready connection when starting their application, regardless of whether it is in the client or Wi-Fi server mode. This is not the case when using bare metal programming, as in the case of RP2040, so the developer must connect to the network manually using their code. Here, the Wi-Fi access point eventually sets up an access point to let other devices connect to it.
Okay, so here we are already connected to the development board, and the first example, it's how to connect to the existing access point. For the safety reason, Wi-Fi setting credentials are stored in the Wi-Fi settings file. You need to explicitly copy this file into the Pico and verify it's here. Obviously, you can also uncomment and provide credentials explicitly in the source file and then comment this section here. So this code will try to connect to the access point and will show up connection details when succeeded. The IP address of the device is 192.168.137.
Sample code connecting to the Wi-Fi router for RP2040 system-on-chip is presented on the screen. Note that this code is simple. In example, it doesn't handle critical situations like broken connections. Setting up an access point in MicroPython is also simple.
Okay, so here is our code that implements a simple access point. Our Raspberry works as an access point device right now, and we can connect to it with a Wi-Fi client, so we can connect to it with other devices or even with the laptop device. Let's run our server. It will implement a network in the addressing space of 192.168.4, and the access point IP address is 192.168.4.1. So to connect to this device, we need to use the credentials defined here as a password and choose the correct access point existing, provide the password. And it instantly connects to the Wi-Fi. So we can see right now the networks, and we can go into the details, see the IP addresses we were given. So here is our IP address, and here is an access point IP address.
Once the connection is established, it is time to implement a simple web service. To ease this process, the developer can use one of the libraries to implement a web service engine, example Flask, as in this sample. Implementing a dummy web service is relatively simple and requires just a couple of lines of code. In the case of MicroPython, in addition to the aforementioned need to manually handle networking connectivity, there is also no Flask library. In this example, the device IP address is 192.168.1.170. And the service is waiting for user on IP port 5000. In both cases, only a web browser is needed to test the service.
As in the previous example, we are connecting to the existing access point. and we don't know the IP address when we connect, so we need to present it here to know where to point our browser later. So that's going to be printed in the terminal here in the bottom. And this code, besides connecting to the access point, it implements a very simple web server that will return a hello iot-open.eu message to the web browser. It runs on the TCP port 5000. Besides just being a web server, it also turns on a built-in LED that is located here in the microcontroller in this corner, so we can observe it in the camera, when the first request from the web comes. So, as in previously, we need to upload a credentials file to Pico. Eventually, you can uncomment here this code and remove importing of the SSID and the password from the separate file. And now we are ready to run the code on the Pico. The server is visible on the web right now under the address 192.168.137. So if I use this in the web browser on the port 5000, I should instantly get a message, hello iot-open.eu, as defined here. And beside, you can see that the LED is on now. So it means that the first request came and we can observe it on the physical device.